Welcome to the launch of our exciting webinar series, celebrating the release of the second edition of Nature's Phoenix, co-authored by Dr. Dominick DellaSala of Wild Heritage and Dr. Chad Hanson of the John Muir Project. This series explores key chapters of the book, diving into fire science, policy, biodiversity, and ecological impacts with insights from renowned experts. In this first installment, we focused on Chapter 8, What's Driving the Recent Increase in Wildfires, which examines the historical context of wildfires and the influence of climate change on their frequency, size, and severity, while also discussing forecasting techniques to understand fire activity and its interaction with climate change.
Well, thanks for everyone for joining us for the first in the Nature's Phoenix second edition wildfire webinar series. I'm really glad you can join us. I think this is going to be a great start to the series. These webinars are being done in conjunction with the release of the second edition of Nature's Phoenix, which is a groundbreaking book on the ecological role of mixed severity fires. And this webinar series, which is going to run basically every 2 weeks through into October, is going to focus on different themes from chapters in the book and bring in some of the authors from the book to share their experiences and insights. And we're going to start today with a very timely topic, which is the climate fire nexus, and looking not just at how climate affects fire, an important topic and one that gets a fair bit of attention, but also an equally important but often overlooked theme of how forest and fire-related policies affect the climate, including policies that may present themselves as climate-informed, but can in fact have the opposite effect of being climate harmful. So we have two speakers today, Dr. Dominick DellaSala and Dr. Chad Hanson, and they're each going to give presentations of, I think, about 20 minutes each. I think it makes sense to save questions until after both of them have presented, because I think each of them brings in themes and they might want to both have a role in answering those sorts of questions. Welcome to everyone who's joined us. I'm really glad that you all can join for what I think is an incredibly important topic. And I think that the insights that are in this new edition of the Nature's Phoenix book, I think, are incredibly timely to our current questions and dilemmas around fire and forest policy, and particularly what it means for the climate crisis, as we'll be talking about today. So to that end, our first presenter is Dr. Dominick DellaSala. He's the chief scientist at Wild Heritage, and he's the former president of the Society for Conservation Biology. He's an internationally renowned author of more than 300 peer-reviewed papers and 9 award-winning books on forests, climate change, endangered species, and speaking truth to power, as well as being an editor for multiple scientific journals. He has been widely quoted in the national media on forest and fire issues. He's served on several committees, including the White House Task Force on Forests, and, including White House task forces on forests, and Oregon's Global Warming Commission Carbon Task Force, which reported to the governor. Dominick is motivated by his work to leave a living planet for his 2 daughters, 4 grandkids, and all those that follow. So here's Dominick DellaSala.
Yeah, thanks, Doug, and welcome everybody. Sorry about the acoustics here, but we'll try to get through this as best we can. To begin, I just want to preface my remarks that I experienced a climate-driven wildfire in my community during the Labor Day event in 2020, where half of my town burned down. And years prior to that, I had been warning people about the increasing relationship between large fires that are affecting the urban environment, climate change, and the misapplication of logging in the backcountry as a presumed solution to this growing problem. And so I think what I would wanted to cover today is chapter 8 in the book, and I hope that you'll purchase that book because it has over 400 pages total and multiple citations. There's hundreds of citations in the book that Chad and I and other authors worked on to put this project together. It's not just the modification of the first edition. There's a lot of new material, updated information in here, particularly relevant to the climate crisis and the feedback between emissions in the atmosphere being put there by burning fossil fuels and the land use sector, particularly forestry, that is contributing to this feedback with the fires that we're seeing today. So I'm assuming you can see my screen. So I'm going to advance to the next slide, which I always have to get a dinosaur shot in here somehow to grab people's attention. And, you know, in the Nature's Phoenix book, we talk about this relationship between plants and fire that's been going on since the advent of plants on the planet hundreds of millions of years ago. And so that's a long time for plants, particularly forests, to develop adaptation strategies to the frequent visitation by natural disturbances, albeit in this case it's wildfire. But this is the part of the interplay between evolutionary and adaptation processes in these forests and the necessary role that fire plays in driving that. So next slide, please. And this one here shows the level of fire and insect infestations in our region now for several decades. And a lot of hype is going on about this as being an unnatural process that can only be prevented by using chainsaws. But these, many of these, especially insect outbreaks, are cyclical processes. They occur on a regular basis, and they are being amplified by the interaction with the climate signal. And what we found in our own research is that even though we're seeing these large fires, there's natural reseeding occurring into the interior of some of the largest high severity burn patches. And so far, conifers seem to be resilient to these effects, but in low productivity areas, it can be delayed for quite a bit of time. And in a lot of the climate models that we've been working with now in several of the dry forest regions in North America, there's concern about the climate niche is shifting on these forests. And in some places, we may not have forests going forward by mid to late century. But, you know, the way to deal with this is not through logging. And as you'll see through my talk as we go forward to the next slide, please. You know, and back in 2011, when I finished my book on temperate and boreal rainforests of the world, I thought I knew what a forest was. I had a pretty good idea of this verdant old growth system that I had been seeing all over the world in temperate and boreal rainforests, until I took a hike with my 8-year-old daughter at the time, and we went to this big burn patch. We came out of the old growth forest, unaffected by fire, and into this big burn patch, and it was striking the diversity of life in these forests being held together by the biological legacies. Those snags that you see in the photo are really holding it together. Wildfire did not destroy the green forest as depicted in that little slide to the right. It actually rejuvenated it because there was so much activity going on in that forest that I had to recalibrate my understanding of what a forest was. And that led to the first edition that Chad and I did with, I think it was 27 other scientists at the time back in 2015. So next slide. So when we look at fire, when we describe fire behavior, two of the main indicators are intensity, which is the level of energy produced by the burn, and severity, which in this case is the effect on the ecosystem. You can see the slide to the right has those little acronyms in there. The H is high severity, L and U is low unburned, and M is moderate. Now you put that together in a landscape mosaic, and you've got the next slide, which is this mixed severity complex. Those mixed severity complexes have exceptional biodiversity at the alpha level, which is within stand, at the beta level, which is going across gradients, and at the gamma level, which is at the ecoregion level. So these are not catastrophes, ecologically speaking. They are rejuvenating the system that is calibrated to deal with these kinds of natural disturbances that shape the biodiversity of fire-dependent places. Next slide. And nature has numerous adaptations that allow it to withstand even the most intense burns. Although that's changing some with climate change, the specific adaptations include, as trees get bigger and grow more bark, they also drop their lower branches, and that makes it really hard for fires to crown out. So the large old trees tend to be more resistant to fire, which we've seen in multiple studies. But even those forests at times will succumb to high intensity burns that kill the crowns. And when that happens, there's all kinds of resilient mechanisms, including seed rain that has been observed in a lot of these high severity burn patches shortly after the burn. Epicormic branching, which the tree appears dead at first, but then sends out a new branch. Same thing with late flushing. The tree appears dead, but it isn't. These are all components of a resilient strategy that forests that need fire have adapted over eons. Next slide. Way back when I was in grad school, we were taught that succession follows a linear trajectory from young or pioneering stage to the late stage or senescent climax period. You can throw that away now, as that no longer is the case with a linear progression like this. It's really circular. So succession occurs at circular levels, connecting all the stages, whether you're looking at it as a tree fall gap in an old growth forest where the new vegetation is racing to get to the top, or an old growth forest that's now complex early xero forest. It's all connected. And anything we do to disrupt that circularity will change the trajectory that those ecosystems are on. And that's why post-disturbance logging is so bad for forests that are rejuvenating from fire, because you disrupt that circularity. Next slide. So what's really important when looking at mixed severity fire is this so-called fire behavior triangle. That's been taught in the textbooks now since the early 1990s in Jim Agee's fire ecology book. But really what's driving the fires today is this top-down process related to the climate that is overriding bottom-up influences, as we will see in the next series of slides. Next slide, please. Now, this pattern is particularly relevant to our region in the Pacific Northwest. On the far left is the early 1900s, where there were a lot more fire acres burning at the time. That was attributed, at least in part, to the warm Pacific decadal oscillation that brings us warm patterns coming out of the Pacific Basin that leads to warm temperatures and drought. Mid-century, there was a cool PDO. And at that time, the Forest Service was scaling up its militarized operations of fire suppression, which led to this lull and sense of security that we could build anywhere we want. And so you had an explosion of homes built in dangerous situations because of this security blanket of a cool PDO and militarized fire suppression extinguishing most of the fire starts. Now, look what's happened since the 1980s. Now, clearly, this figure needs to be updated with more recent data, but you can kind of see the pattern with a warm PDO that's kicked in from climate change from the 1980s. We're seeing an increase in fire acres. Next slide. And what's really the top down driver is, as we know, climate change. We are experiencing more heat domes in our region, more droughts, early snow melting, and less snowpack. All of that feeds back on wildfire behavior, of which is governed increasingly by the amount of emissions that we're dumping into the atmosphere from land use and burning fossil fuels. And land use, in our case, involves forestry, but it also includes, livestock out there in terms of methane production and other uses. Next slide. So I'm going to pull right from some of the facts in Chapter 8. What we did in Chapter 8 is we had a series, I think it was 21 facts that refuted the naysayers in terms of the climate signal happening from human activity, and also in relation to the increase in wildfire behavior that is overriding the bottom-up factors. And so some of those top facts that you see there all pertain to, look, there's no longer an argument in the scientific community that climate change is happening. Everyone knows it is, and that it's human caused. We don't even debate this in the scientific community. Where the debate is happening is at the policy level, and the disinformation that is being used by the fossil fuel industry, the timber industry, and all those that support those, and in return get supported by those industries. So that's what this is laying out here, that we are on a path to major catastrophic consequences. The world is is closing in on the 1.5 degrees centigrade safety net for atmospheric and biospheric stability. And we are not reducing our emissions. The emissions remain at unprecedented levels. We're in a major climate and biodiversity crisis. We're seeing more heat waves, more droughts, more fire behavior, more compounded flooding. So all of that's happening as a result of this connection at the large global scale, feeding back on wildfire behavior. And most of the effects that are outside of what we would think are characteristic for fire behavior are occurring in the heavily logged landscapes, not in the areas protected from logging, and not in the areas that are old forest and intact areas that are serving as climate and wildfire refugia. And that study referenced by Lesmeister et al. Is from government scientists that found that the owl forests in the range of the spotted owl were functioning as wildfire refugia, and a subsequent study found that older forests are also functioning as thermal refugia. Their temperatures are much cooler than the surrounding areas. So why the heck are we logging these places for fire control? Makes no sense. Next slide. Some additional information about the buildup of fires in our region as a result of the climate signal. And similar patterns are being observed throughout Western US, in Canada, particularly in British Columbia now, and in Eastern Canada, where it's been documented, in Europe and Australia. We've got a paper that we're working on with several colleagues that is bringing all of this together in the different biogeographies, showing similar patterns that I'm going to be showing you soon. Now, how soon do we close that wildfire deficit that has been from historic times, when you saw that earlier graph of the early 1900s, to contemporary times, and then moving forward in a shifting climate, really depends on how far removed we are from that 1.5 degrees centigrade threshold. But what we're seeing is the number of days with extreme wildfire danger has more than doubled in most regions due to the climate signal. Next slide. Now, the key climate change finding in this, in relation to what it all means for humans, is excessive smoke levels are now being associated with increasing morbidity and increasing asthma and other problems. And you can see the smoke plume there in that slide, that smoke travels quite a bit of distance when it gets picked up by the jet stream. It can affect fires on the West Coast can affect air quality all the way on the East Coast, which is why I have a major problem with organizations like the Nature Conservancy that in our region is claiming that by thinning in the backcountry, they're going to reduce the smoke in our region. And right now, where I live in Southern Oregon, we don't have any fires in our region specifically, but nearly every day we're baked in smoke from fires that are surrounding us because the air sheds are all connected. And it really comes down to the climate and how smoke moves around over large distances. You cannot affect that at a local level when we're being inundated by it from fires coming hundreds of miles away. Next slide. So I mentioned that there is emerging biogeographical patterns that we're seeing that in logged areas, the fires are running hot and fast. We've seen it in Oregon, the Western US, in Victoria, Australia, and in Eastern Canada. The slide that you see at the bottom there is for a paper that we currently have in review that is showing that there not only were extraordinary levels of logging in Quebec and Ontario, but those same areas that were logged were burning in the highest fire intensities during those fires that had inundated the East Coast all the way down to the Carolinas with smoke. And yet we had all kinds of talking heads on CNN and other news stations blaming it on forest management. Well, in part, they're right. It's not because of the lack of logging. It's because of too much logging interacting with the climate signal. Next slide. So what it comes down to is teasing apart the climate signal in relation to wildfires. This is one of the most exciting fields of climate change modeling. It's called climate attribute modeling, where we can now, with some degree of reliability, attribute particular major events to the climate signal. And what we're finding in those biogeographical studies that I pointed to in the last slide is there's a simple equation here for large fires. It comes down to the summer temperature increases, heat domes, plus drought. And one measure of drought is the vapor pressure deficit, the amount of moisture in the atmosphere, plus the slope and aspect position, south versus north facing, elevation, areas burn differently, the vegetation condition, logging, and roads. That's the equation. Not all those factors are equal. Summer temperatures and the vapor pressure deficit in some regions can drive 50 to 100% of the fire increases. It's regional and context dependent. As far as the bottom-up contributor in vegetation, native ecosystems have those resistant and resilient components to fire, like the old forest, but they're being transformed by logging into flammable plantations that carry fire across vast areas. And then we have the road issue, and that we know in areas with a lot of human access, the probability of fire ignitions goes way up. And in fact, 80 to 90% of all wildfire ignitions across the US have a human component to them. So we've got to do something about roads, and that's almost never mentioned in any of the so-called fuel reduction projects. And then we have the problem of livestock, transforming the understory vegetation, shifting it into flammable weeds. Again, none of that is dealt with in the so-called fuel reduction projects. Next slide. Okay, so I'm getting down to my last two slides. So what can we really do about this? And I think it comes down to, we've got to be involved with both the top-down and the bottom-up mitigation and adaptation issues. So with respect to the top-down drivers, we've got to solve first and foremost for the climate and biodiversity crisis. Logging does not solve either one of those. It amplifies those crises. Any strategy that doesn't solve for the root causes is going to fail. We can't log our way out of this. Thinning, prescribed burning, whatever you're looking at, it won't work at scale, and it will have significant impacts to ecosystems, including releasing more emissions into the atmosphere, feeding back on fire behavior. So we got to cut emissions across all sectors, protect the natural areas as climate solutions, and we got to link that to adaptation strategies by reducing cumulative human stressors on those forests. Next slide. Bottom up, I don't deny that some forms of active management can lower fire intensity, but that window is closing quickly because of extreme climate fire weather will override bottom-up factors. And to do any kind of active management, you need to leave the forest canopy intact. And most of the projects don't do that. They overventilate the system so that fire carries fast through the understory, which also responds to increased light levels, and you get a drying out effect. So land managers and organizations like the Nature Conservancy that are pushing this as a solution are fooling themselves and the public into thinking that this is going to solve the climate and biodiversity crises. We also need to look at smoke shelters, air quality filters in all homes that are in fire systems, but those are really Band-Aids. They don't solve the global problem. They just allow us to adapt to a certain degree. And of course, home hardening, defensible space, and better road management to reduce human-caused ignitions all need to be part of that. And the last thing I'll say is this almost never gets mentioned, but the impact of livestock grazing on top of all the logging is definitely not a strategy that is consistent with the adaptation that is necessary to get these forests through their bottleneck with climate change. So I'm going to end there, and I'm going to turn it back over to Doug, and then we'll just take the questions later in the chat that will be orchestrated by Doug. Thank you.
Great. Thank you, Dominic. And just one clarification on that. As Dom said, we're going to do questions after both presenters are done. But post your questions in the Q&A section is the place to post your questions. And so with that, let me introduce our second speaker, which is Dr. Chad Hanson. He is a research ecologist and director of the John Muir Project of Earth Island Institute. John Muir Project is headquartered in the Sierra Nevada mountains of California and also has an office in Washington, D.C. Chad has also served on the National Board of Directors of the Sierra Club. He has a PhD in ecology from the University of California at Davis, with a research focus on fire ecology and conifer forest ecosystems. He's published several dozen scientific studies and articles in peer-reviewed journals pertaining to forest and fire ecology and climate change. In 2017, the New York Times described Chad as being on the, quote, cutting edge of ecological research, end quote. Chad is the author of the 2021 book, Smokescreen: Debunking Wildfire Myths to Save Our Forests and Our Climate. And he is the co-editor, along with Dominick, of the 2015 book, Nature's Phoenix, and the newly released second edition of that book. So let me turn it over to Chad now. Thanks.
Thanks, Doug, and thank you, Dominic. Much appreciated. And thank you, Jen, for all the work in getting this going. All right, so I'm going to talk today for about 20 minutes here before we do Q&A about what we call the overgrown forest narrative, and how that's really a new type of climate change denialism. And everyone's heard some version of this narrative many times, that the idea that our forests are overgrown, there's too many trees, there's too much biomass in the forest, and we need to roll back environmental laws and minimize public participation so we can remove most of the trees through thinning and other so-called fuel reduction activities to curb wildfires. That's the narrative. And I'm going to talk to you about what the emerging science is really saying about that. Next slide, please. All right, so this is just a couple of quotes from a letter from November of 2021 to President Biden and Congress, just talking about the climate change impacts of logging, including thinning. Logging in U.S. forests emits 723 million tons of uncounted CO2 into our atmosphere each year, more than 10 times the amount emitted by wildfires and tree mortality from insects combined, end quote. Again, these are over 200 scientists, climate scientists, forest ecologists, and quote, most of the carbon removed from forests through logging is emitted almost immediately, end quote, as a result of burning of small trees, slash debris, and mill residues from biomass for biomass energy. So in other words, a very small portion, a minor portion of the carbon in a given tree that's removed for logging ends up in a 2x4 somewhere in a house. Most of it goes into the atmosphere almost immediately. Next slide. And this is a slide that just shows you the massive climate change impact of burning trees or portions of trees for energy, basically turning to our trees like they're sticks of coal, what we call biomass logging. And whether that's the wood pellet into the wood pellet industry that's destroying the forests of the Southeast for export to use wood pellets to power the grid in Western Europe, or whether it's just chipping trees and burning them for energy on site to power the grid in the West, like we're seeing in California and many other Western states. What this graph shows is that burning trees for energy produces substantially more CO2 even than burning coal for equal energy produced. So in other words, it's hard to be worse than coal from a climate change standpoint, but burning trees for energy is worse than coal. In fact, it's substantially worse. It's about the dumbest thing we can do from a climate change mitigation standpoint is turn to our forests as a source of energy production. Next slide. And the reason I mention this is that that's increasingly common. These so-called thinning projects, the majority of the carbon being removed from the forest in most of these current thinning projects is ending up as kilowatts, as biomass, as dirty fuel, dirty energy. And this is just an article just talking about the push by the biomass logging industry, including global giants, multinationals like Drax, and Enviva, trying to make pushes into California's forests, other forests of the West, Oregon as well, and basically due to the forests of the West, what they've been doing for years to the forests of the Southeast. Next slide. And one of the myths that they're selling to the public and to policymakers is that they'll capture the carbon and then they'll pump it underground. They'll build thousands of miles of CO2 pipelines. They'll pump the CO2 underground and they'll store it there and everything will be fine. So don't worry about the CO2 emissions. That is an absolute sham. That's another form of climate change denialism, and it's a false solution. The reality is these carbon capture facilities have consistently been found to capture only a minor portion of the CO2. And there's substantial increases in carbon emissions from all of the manufacturing and installation of that machinery, that equipment, and the pipelines. Air pollution into communities increases because the particulate and toxic emissions are not captured, and the biomass industry already disproportionately impacts environmental justice communities. They're bearing the burden the hardest from this industry. It diverts critically needed funds and away from solar, which is a problem. And CO2 pipelines break and they leak, and it releases CO2 into not just the atmosphere, but also into communities. CO2 is deadly, or it can be. And we recently saw this happen in Mississippi, and hundreds of people went to the hospital. Fortunately, no one died in that event, but it could have easily been much worse. Not only that, but pumping CO2 underground increases earthquakes and causes more release of CO2, which again threatens communities and worsens climate change. So this is a 21st century snake oil salesmanship. It is not a solution, and the solution is, as my colleague Dr. DellaSala mentioned, is to rapidly transition away from fossil fuels and dramatically increase protection for our best carbon sinks, and that especially means forests. Next slide. And Dr. DellaSala and I, with Dr. Mark Harmon, spent 4.5 years on a field-based study in 2 large fires in the Sierra Nevada. trying to answer this question because there's a lot of mythology about what happens when you have a big fire in the forest. A lot of people think the trees are just incinerated and they just go poof into the atmosphere. I get calls on this all the time, and they think all that carbon is just lost to the atmosphere when trees are burned or when they get killed in fire. We found that nothing could be further from the truth. That in fact, on average, across these big fires, rim fire and creek fire, the two we studied, that the only 1.2% of the carbon in these trees is actually consumed and emitted into the atmosphere. 1.2%, less than 2%. So the point is that, yeah, there's carbon emitted in a fire, of course, but it's much, much less than we've been assuming for many years. And not only that, because of the nutrient cycling and the natural regrowth that occurs, the shrubs, the oaks, the conifers, that carbon is recouped from the atmosphere and brought back into the forest surprisingly quickly. Next slide. On the other hand, thinning, so-called, which is just a euphemism for logging in almost every case, thinning emits about 3 times more CO2 into the atmosphere per acre than wildfire alone. So it is a climate change nightmare. It is a terrible idea from a climate change standpoint. And that's even if you assume that thinning will reduce fire behavior, which it often does not. Trees under 21 inches in diameter, what we often call smaller trees, in one study, they comprise 58% of all above ground carbon. And of course, in many of these so-called thinning operations, they remove large trees too, but they also basically clear cut the understory. They leave very little left, and it can be a huge reduction in forest carbon storage. Next slide. And as Dr. DellaSala mentioned, wildfires are driven mainly by weather and climate factors and by climate change. Drought years, hot, dry, windy conditions. This is what drives fires, and these are the overriding top-down drivers. It's not about forest density, but to the extent that forest density matters at all, it matters in the opposite direction from what the logging industry and its political allies have been telling the public and the press. Next slide. This is another quote from the letter from over 200 scientists to President Biden and Congress. Quote, "We have watched as one large wildfire after another has swept through tens of thousands of acres where commercial thinning had previously occurred." End quote. In other words, these are weather and climate-driven events. These thinned areas are not stopping wildfires. In fact, wildfires are sweeping rapidly through these areas and oftentimes more intensely. But that's not the only impact. It's actually worse than that. Next slide. So not only are these wildfires sweeping through more rapidly, the fire is not destroying the forest, but when it sweeps through the forest more rapidly because these forests were thinned, it reaches the community more quickly. And we saw the tragic consequences of that in 2018 in the Camp Fire, which devastated the town of Paradise. 86 lives lost, over 14,000 homes destroyed. And that fire in the first 6 hours burned through some of the most heavily logged forests in the northern Sierra Nevada, massive areas of thinning, dead tree removal, live tree removal, supposedly, fuel reduction and fuel breaks. Well, that's what the fire burned through most rapidly. And people had far, far, far too little time to evacuate. And we saw the tragic consequences of that. Next slide. And the scientists, the over 200 scientists go on and explain why the thinning can alter fire behavior in this way. Quote, "Removing trees can alter a forest microclimate and can often increase fire intensity. In contrast, forests protected from logging and those with high carbon biomass and carbon storage more often burn at equal or lower intensities." End quote. And my colleague Bryant Baker and I found that thinning kills significantly more trees than it prevents from being killed. A little note here for those who follow the research on this, all those Forest Service studies that they crank out and claim that thinning is effective, they don't account for the trees killed by thinning itself. It's a massive source of bias and really just an unconscionable omission from a scientific standpoint. to say that that somehow thinning is reducing tree mortality, which it's not, but then to fail to disclose the percentage of trees killed by thinning itself before the wildfire got there. And typically it's most of the trees in a stand. Next slide. And now more and more U.S. Forest Service studies are breaking ranks with the political narrative of the agency, this overgrown forest narrative, and they're following the evidence, some of the Forest Service scientists, but more and more, and they're concluding that the political narrative is not true. In fact, it's the opposite. There's a massive 30-year study of several hundred wildfires by U.S. Forest Service scientists, and they found that the more open forests with lower biomass had higher fire severity. And they explain this because such forests, quote, have hotter, drier, and windier microclimates. And those conditions decrease dramatically over relatively short distances into the interior of older forests with multi-layer canopies and high tree density, end quote. In other words, denser forests with higher tree densities and higher canopy cover have a cooler, more moist microclimate, and they are not as hot, not as dry, not as windy, and they tend to burn at lower fire intensities, relatively speaking, all things being equal. Next slide. And, you know, we see this all the time. This just shows this is the western side of the Caldor fire in the northern Sierra Nevada in 2021. Those black polygons, those are areas that were thinned. And of course, the fire burned through those areas at high intensity, just like it did in the unthinned forests on that particular day, a day and a half or so, because that period of time was especially hot, dry, and windy, and it was a drought year. So the weather and the climate factors and climate change were the overriding top-down factors. It didn't matter that they were thinned. Those thinned areas burned at high intensity, just like the unthinned forest did. The difference was they had far less carbon in them because most of the carbon was removed by thinning. And in some cases, it was not most, but it was 20 or 30 or 40% of the carbon. And so that carbon isn't mostly in the atmosphere. Next slide. Another study by Forest Service scientists, and this one was in the Rim Fire, Leiterson et al. 2014, they found that, quote, plots with greater white fir basal area, a species generally associated with greater sensitivity to fire, tended to burn with lower fire severity, end quote. And that's a really important finding because, part of the mythology is that there's too many fir and cedar trees and somehow that's increasing fire severity. Well, the data don't really bear that out. They also found, quote, the density of small to intermediate sized trees were also related to rim fire severity, with plots with a greater small tree density tending to burn with lower severity, end quote. So there's a fairly large and growing body of research that's finding this. Denser forests, more carbon-rich forests, oftentimes with higher tree densities, are tending to burn at lower severities, not higher. Next slide. And, we saw this again in the Dixie Fire, very large fire in 2021, northern Sierra Nevada. Those orange and yellow polygons that you see, those are all areas with some form of logging. Much of it was thinning, and the fire burned through those areas very, very rapidly. In fact, the very fastest day of spread was through the area that had the most thinning. Next slide. And, so this is what it often looks like when these areas are thinned. And of course, the thinned areas burn mostly at low and moderate severity, just like the unthinned forests burn mostly at low and moderate severity. The difference is that thinning can oftentimes burn at high severity too, and thinning kills more trees overall than it prevents from being killed, especially in combination with the trees killed by thinning itself and the trees killed by wildfire. And so, this mythology that if a forest is very open, if it's very open and low density from thinning, that somehow it won't burn at high intensity, that's utter mythology. They very often burn at high intensity. That's common. This is an example of that. This forest was thinned, and you can see the very low tree density. It was thinned prior to the Creek Fire that burned in the Sierra Nevada in 2020. And of course, this area burned at high intensity. Next slide. And there was another study by Forest Service scientists. This was Lesmeister et al. 2019. So this is yet another one. And they found that denser, older forests with high canopy cover had lower fire severity and they quote, buffer the negative effects of climate change, end quote. In other words, they actually have a kind of a mitigating effect. They have an insulating effect against the extreme weather driven by climate change. The authors concluded, this is the last long quote I will quote, but it's important. Quote, thinned forests have more open conditions, which are associated with higher temperatures, lower relative humidity, higher wind speeds, and increasing fire intensity. Furthermore, live and dead fuels in young forest or thin stands with dense saplings or shrub understory will be drier, making ignition and high heat more likely, and the rate of spread higher because of the relative lack of windbreaks provided by closed canopies with large trees, end quote. In other words, once again, denser forests tend to burn at lower intensities. They slow the rate of spread. More open forests, including those that have been thinned, tend to have faster rate of spread and oftentimes higher fire intensity because of that microclimate effect. Next slide. And I'll just talk just for a few minutes. I'm just about wrapping up here, but I just want to talk about the ecological impacts of thinning too. Like I said, in many cases, it's basically an understory clear cut. And the reality is that we don't want orderly forests like you get in thinning, where it's just a sort of bare ground and widely spaced live mature trees and really nothing else. That's not really a forest ecosystem anymore. Forest ecosystem is complex. It's messy. That's biodiverse, and forest ecosystem that's complex and messy is biodiverse and carbon rich. This is an example of that. This is a California spotted owl nest territory in the San Bernardino Mountains. And you can see the snags and the shrubs and the down logs and the live trees, dead trees. It's a rich and complex ecosystem, but it is not orderly. And thinning really basically removes and reduces and degrades that complexity. Next slide. And this is an example of that. You know, there's part of the mythology in the Forest Service. Some of the Forest Service scientists who are still promoting the discredited overgrown forest narrative, they try to spin this in the press all the time and say, oh, well, we're just removing small trees and underbrush in these thinning projects. That, of course, is an outright falsehood. They're removing small trees, medium trees, and large trees. But they create this impression of people out there with pruning shears instead of bulldozers and chainsaws and feller bunchers and giant industrial equipment, cutting down, most of the trees, including big trees, and churning up the ground. This is what it looks like after thinning. This is not a light touch operation. They're not removing all of the trees, but it's closer to a clear cut in many cases than it is to anything else. Next slide. And one of the arguments that they use is they say, well, we want to prevent high intensity fire from happening. Well, why? High intensity fire is a natural part of the mix. You want low intensity, you want moderate intensity, and you want high intensity fire. You want the mix. That mix is natural. It goes back millions of years, and many species have evolved to depend on different levels of fire intensity. Some like it hot. Blackback woodpeckers there on the left of the image are one of those species. And it turns out spotted owls like the high intensity fire patches for foraging. They nest and roost in the lower moderate or unburned, but they go out of their way to forage in the high intensity patches. Next slide. And, natural conifer regeneration is tremendous, even a long distance from the nearest live surviving tree, which is not that common. Most high intensity fire patches are relatively, small or medium sized, but some are big. And the forests regenerate there too, just wonderfully. This is an example of that in the rim fire, 8 years post-fire, over about 1,000 feet from the nearest live surviving tree. Next slide. And this is the area immediately adjacent to it that was logged for biomass. We call this clear cuts for kilowatts. And you can see the devastation. This area was regenerating amazingly too. The snags were storing carbon, the down logs were storing carbon, and there was an enormous amount of carbon sequestration and storage in the natural regenerating forest. Many of the trees were already over 12 feet tall when they did the logging project. And of course, now the carbon is almost entirely gone from this system where they did the logging. Next slide. And same thing in giant sequoia groves, enormous, amazing natural regeneration, carbon storage in the snags and down logs, carbon sequestration and storage in the regenerating forest, the sequoias, the shrubs, just amazing rich ecosystem, contrary to what the some of the government agencies, the Forest Service and the Park Service, and some pro-logging NGOs have been misleadingly telling the public, claiming that sequoias won't regenerate in high intensity fire patches. It's actually the opposite. That's where they regenerate by far the best, is in the high intensity fire patches. But that overgrown forest narrative, that mythology, is leading to some really destructive management policies that are hurting forests and hurting the climate. Next slide. And this picture was I took this in the exact same grove, in the exact same high intensity fire patch, just about a couple hundred meters to the east from the last picture. And this area was post-fire logged for much of it for biomass energy, more clear cuts for kilowatts. And they said they did it for restoration, fuel reduction, and reforestation. So you tell me, does that look like reforestation to you? It sure doesn't to me. It certainly doesn't look like restoration or forest carbon storage. Next slide. And this is a similar circumstance and devastation from post-fire logging and artificial tree planting on Save the Redwoods League lands. And people don't realize that Save the Redwoods League is actually involved in the commercial logging business. They are a pro-logging organization. They do a lot of destructive logging, and they have an ugly history in that. If you've read the book by Greg King, The Ghost Forest, you'll find out a lot more about that in the coast redwoods. But they're also doing it in giant sequoia groves in the Sierra Nevada. And this is an example of that. And if you look closer, you can see many of the trees they planted, the sequoias they planted after they devastated this area with logging and herbicides. Those seedlings have already died, just baking in the sun. Next slide. And so what's the alternative? What's the other way to go? The other way to go is 180 degrees away from what we're doing, and that is pro-forestation. That simply means protecting forests from logging, so that they can, for biodiversity purposes, and so that they can maintain and increase their carbon storage and help us draw down that dangerous excess of CO2 in our atmosphere. We need to keep the carbon in the forest, and we need to keep the carbon in the ground. Both things are equally important at this point, at this stage in the climate crisis. We cannot overcome the climate crisis only by moving away from fossil fuels. That's essential, but it's equally essential that we protect our carbon sinks from carbon removal, and forests are the best carbon sink we have. And for more information, you can, of course, get the second edition of our Mixed Severity Fires, Nature's Phoenix book that Dr. DellaSala and I co-edited, and visit the John Muir Project's website. And also, next slide, you can get a copy of my book, Smokescreen. And I'll stop there, and I'll be happy to answer any questions with Dr. DellaSala.
Great. Thank you both for excellent presentations. As a reminder, we're asking people to please post their questions in the question and answer section online. So I'm going to start going through those. Let's see. Let me start with a question on has the Forest Service or timber industry in general considered reallocating funds towards home protection and evacuation assistance, given the clear evidence that land treatments are not effectively managing, in quotes, fire risks as intended? If not, what barriers, besides profits, do you believe are preventing this shift in focus?
I can start on that, and if Dr. DellaSala wants to, add in, he may have something on that too. But it's a great question, and the answer is, yes, the Forest Service has been asked to shift funds away from backcountry logging, including thinning, and shift it towards measures that will actually protect communities that are proven to be effective, like defensible space or home hardening. They have consistently refused. I've asked them numerous times in comments, and they have told us that that doing so is beyond the scope of their consideration, because they say that that backcountry logging is the most effective way to go. Now, of course, the evidence contradicts that dramatically. And actually, we're in court right now. John Muir Project is in court against the Forest Service right now over two different logging projects on that very basis, because we said under the law, they were required to consider the abundant science, including by their own scientists, that says their current practices are completely ineffective and counterproductive in terms of community safety.
Yeah, I'll just drop in an additive to what Dr. Hanson just said. But, you know, I witnessed the burning down of in the Labor Day fires of 2020. And a year before that, I actually did a briefing session with two of my local representatives, state senator and a local representative, and we actually had a beer together. And in the process, I laid out all the science, and I said, you guys are directing funding to the wrong places. And you're being misled by organizations like the Nature Conservancy that are tapping into large pools of money and claiming that this is going to protect communities. Now, fast forward a year later with fires in the heat dome that we had during the September of 2020, which then burned down my community and was quite traumatic to me and everybody that lives here. And I sent photos back to those two representatives, and I said, basically, this is what I was talking about. And because the funds are not being redirected, this is going to happen to more communities across the Western United States. And by the way, the town has now completely rebuilt itself out of the ashes, which is something that I celebrate often every year when we have the anniversary of the Alameda fire here in Southern Oregon. But they did so with no defensible space and no home hardening. So they just built right back on top of the prior fire footprint, like it's not going to happen again. And maybe it won't, but maybe it will. And we've seen examples in California of towns that have burned down more than once over, 4 or 5 decades. And it could come back to haunt this community again because the funds are being misallocated.
Great. Thank you both. So there have been a few questions related to carbon accounting, and I'm going to try and combine a couple of them. One references one of your slides that talked about 723 million tons of unaccounted CO2. Can you address carbon accounting? And there have been a few questions that ask about it in relation to biomass and comparing biomass to coal and so forth.
Yeah, well, this could be a webinar unto itself. Honestly, this question, it's so central and it's so important, and we may actually do that at some point in the near future. But the bottom line is this: is that the massive amount of carbon emissions, CO2 emissions annually from logging in the United States are not accounted for. They do not show up in EPA reporting. This is not a scientific decision. This is a political decision. And the public and policymakers are being misled, and the press is being misled into thinking that logging doesn't emit carbon. And it's based on again, a political fiction that if whatever carbon is emitted will simply can be treated as if it was never emitted, because at some point the trees will regrow and they'll reabsorb the carbon. So you can treat all logging, including biomass logging, as carbon neutral. Now, this is a totally discredited notion from a scientific standpoint, because of course, carbon emitted now, in some cases, may never get reabsorbed because of the soil damage done by logging. That's a reality, or at least not in any time frame that matters for humans. But even when the forests regrow, there's a massive delay relative to all the carbon that will be stored and absorbed in a mature forest that continues to grow and absorb carbon. So it doesn't catch up. And not only that, and most importantly, the carbon that's emitted is not even close to recouped during the time frame of the climate crisis that matters so much, the next few decades, where it's a make it or break it, whether we actually change our ways and bring those dangerous CO2 levels and our greenhouse gas levels in our atmosphere down, get away from fossil fuels and protect our carbon sinks, or whether we continue business as usual and nature will solve the problem for us. Either way, things are going to change. So this is a political issue that needs to be addressed. The fact that this massive amount of carbon emissions, which the scientists point out is on par, it's comparable now to the annual carbon emissions from burning coal in the US. That's how big the carbon emissions are from logging, yet they're unaccounted for. It's just a massive, massive misrepresentation on the part of agencies.
Yeah, let me jump in just with one real quick point on that too. And I get a lot of requests from groups in BC, in the Pacific Northwest, in California, in Montana, to do carbon life cycle analyses on their timber projects that they're fighting. And I'd love to do that. We need the proper accounting tools. We know how to do it. It's just a matter of getting the information on the ground and throwing that together into the life cycle analysis. We did this for groups in the inland rainforest of British Columbia, but it actually involved being out on the ground, taking measurements, using plot data, using remote sensing data, and then building the model that would allow for a life cycle analysis of here's what the existing conditions are in the intact forest, and here's what the logging project is going to do in the way of emissions. So the consequence of not having that is we're seeing all across the board Forest Service projects that do these shoddy environmental impact statements of, well, you know, we looked at it and the emissions are so insignificant when we compare them to the total emissions across all U.S. sectors, it's a drop in the bucket. But that's the wrong scale of the analysis, and they get away with this all the time. And somebody needs to litigate it because it's just not a hard look in the sense of NEPA on accounting for the carbon of those projects relative to not doing the project. That's the appropriate scale, not comparing it to the entire U.S. emissions sector and claiming that we looked at it and it doesn't matter. Because if you do that, then it's a death by 1,000 cuts and we never have a climate solution.
Thank you both on that. We've also gotten a few questions related to the media coverage of fire issues and expressing a frustration over the current state of media coverage of that. One of those questions asks, what are the best ways to get journalists to do a better job covering the science challenging the, quote, log to save communities in the forest, end quote, narrative? What are your thoughts on media outreach?
That's another question that's just so good and so central. Again, it could almost be its own webinar, maybe should be. Let me just say this. You know, we both Dr. DellaSala and I, and many of our other colleagues, you know, we spend a certain amount of our time and energy doing the primary research and publishing studies in scientific journals and writing science books like the Nature's Phoenix book to inform people and to move, you know, scientific knowledge forward. But we spend just as much time just trying to connect that knowledge, that emerging knowledge, with the public, policymakers and the press, so that they don't continue to promote ideas that are outdated or discredited. And we are making progress there, but there's a long ways to go. So I'll say this. There are some environmental reporters who are doing a really pretty damn good job on this. They really are. They're paying attention to science. They're not just talking to Forest Service scientists or university scientists who are funded by the Forest Service. They understand they need to talk to independent scientists, both forest ecologists and climate scientists. And they're doing that. And their reporting reflects that work, that homework. There are others who are aware that there's a lot of science out there that's contradicting this overgrown forest narrative that, as I argue, is a new type of climate change denialism. And they're aware of the science. They've talked to independent scientists like me, like Dr. DellaSala. They've talked to others. And yet they never mention it in their reporting. And they continue to just quote Forest Service scientists who are promoting thinning and other forms of logging and carbon removal. And they never talk about the climate change impacts of that. They never talk about all the science saying it's not effective and it's doing a lot of damage. And I don't know what to say about that. I think that's a problem. I think that's a form of bias, and that needs to be addressed. And I think we all need to do more to address that, and not just with scientific studies, but also letters to the editor. Anyone can do that. Holding reporters accountable, holding news outlets accountable, social media too.
Yeah, and I think both our organizations have done a good job of trying to get the press out in the field, let them see it for themselves. I know, Chad, you've done a lot of field work with media, walking them through the sites, and that's helped. We had a really good article that came out of The Guardian last week. I don't know if folks saw it, on mature and old growth forests. And both Dr. Hanson and I were quoted in there, and it was probably the best story we've gotten thus far on mature and old growth, because it was mostly, you know, the information that we have been trying to get out there now for quite some time. But I think, you know, just getting people on the ground to see these places, and one of the first things is to let them see that these forests are dynamic. They go through stages, and this is not a death of the forest, it's a rejuvenation of the forest. There's some really great online tools showing this. I mean, Ralph Blomer's team has done some fabulous videography work where they show the forest right after the burn, and then they speed up the video going across different seasons. And you can see for yourself that this is not a dying. This is a rebirthing, and it comes with amazing biodiversity. So if you can at least walk folks through the fact that these are really critically important places, hopefully that will then elicit a different response of care, stewardship, and not doing to these forests what we've been doing to them, thinking that, you know, the chainsaws are the solution, that the forests aren't going to come back, they need to be logged and planted, when in fact they're doing quite all right by themselves in most of these settings. So I think that's the first order of business, is just to build a sense of appreciation. And I think that's what we've tried to do with both editions of the book, and that I think has also had some really positive effects on some of the work that the videography folks are doing now in these forests, documenting that they are amazing places, just like an old growth forest is an amazing place too.
Yeah, and if I can add to that briefly, it's so well said. I just want to add that, you know, it's so many times, you know, I'll have you know, people call me, or sometimes environmental reporters, and they'll say, well, you know, that fire, you know, over 40,000 acres burned at high intensity, and it's lost. And you know, to Dr. DellaSala's point, it's not lost. It just went from one form of important habitat to another form of highly important, highly biodiverse habitat that supports a different plant and animal community of native species. The carbon's still there, almost all of it. You know, and so I just say to them, you know, like, lost, I mean, where'd it go? I mean, come out in the forest with me and see for yourself, you know, all the rich biodiversity and carbon storage out there. So, I mean, I think that we, you know, we can, all of us, you know, not just the scientists, everyone, all of us can really help confront and challenge and debunk that dangerous narrative that's driving these bad policies.
Great, thank you. So there are a number of questions that are touching on two things that are distinct but overlapping, which is cultural burning and prescribed fire. For example, on cultural burns, someone writes, there's a lot of talk in media about cultural burns as the solution to wildfires, and that colonialism stopping the practice is the root cause of wildfires. I was asking you to discuss that. Likewise, there are some questions regarding prescribed fires that ask when they might be appropriate and when they might be harmful.
Well, if you don't mind, yeah, go ahead. I'll follow you.
All right, thanks, Chad. So I think there's three issues to really describe anthropogenic fire influence in relation to this question. First is the issue of pile burning, which sometimes and often actually is conflated as prescribed burning. It's not. And pile burning has enormous impacts to soils, to mycorrhizae connections. It's usually followed with shrub mastication and other forms of vegetation treatment. A lot of the shrubs that they're removing have nitrogen fixing and mycorrhizae properties that are essential for forest renewal and yet they get burned up in piles. Then you've got prescribed burning. And prescribed burning is seldom conducted by itself. It's usually done in association with some sort of logging event. And it could be done broadcast burning, and that would be a much different effect than if there was pile burning involved. But coupling with logging is really a problem because it's not going to have beneficial effects at that level. And then the third factor is cultural burning, which is a whole different relationship, much more holistic connection between fire, biology, and culture. And I think that's the most important of those three types of anthropogenic burning sources. But I will say this, while it's important, while I totally support it, and while I think it's necessary to restore the indigenous connections that were in place before colonialism, it's not going to solve the fire problem. It's limited in scale and application when you've got an issue here that is much bigger than what we can affect on the ground. So it's going to have some local beneficial effects, but it's not going to solve the problem writ large.
Yeah, and I'll just add to that this is a really important question, and it comes up in a lot of our webinars, and it's important that we keep talking about it so people understand that, as Dr. DellaSala mentioned, there's wildfire, there's prescribed fire, and then there's Native American cultural burning. They're all distinct. And they all have a role. For me, the important thing is that whether it's Native American cultural burning or prescribed fire, they will influence fire for a certain period of time, but that period of time is very brief, and they won't stop a wildfire. And so a wildfire will still burn. The material that actually carries flames, the pine needles, twigs, grasses, the small diameter material, it can reaccumulate to pre-burn levels within as little as 2 or 3 years after prescribed burning, or any kind of low intensity burning, which could include cultural burning. So the point is, for me, is that cultural burning by Native American tribes has its own intrinsic value to tribes. Tribes have their own reasons for this, and they're the best source of information as to why they burn and why it's important to them. It can have significance and important for basket weaving materials or forage production or animals that they have traditionally hunted. It has religious significance for tribes. It can be important as a fire protection measure, as a perimeter around villages. So this has got importance for tribes that's unique to tribes. It's not about trying to prevent wildfires as some kind of externalized goal. That's really an objective of non-Indigenous agencies, state and federal. And so for me, the way I look at this is the science is really clear that historically, before colonization, before fire suppression and logging, Native American cultural burning was substantially more common than it is today. It was much more common. So was wildfire, mixed intensity wildfires in forest ecosystems. Now it's getting closer to natural levels with climate change, as Dr. DellaSala mentioned, but we're still in a deficit. And so I see common cause, actually. We need more wildfire to get back to natural levels, and we should allow more Native American cultural burning, simply because there's a lot of racist policies that go back a long ways that have suppressed and marginalized and prevented cultural burning. But what I don't like to see is folks trying to pit one against the other, driving a wedge between indigenous communities who want to get back to cultural burning and forest conservation organizations that are trying to protect the important wildlife habitat and carbon storage created by mixed intensity fires. I think we have common cause. I think we should support each other. And I think we should really push back on anyone that tries to drive a wedge.
Thank you. Another question asks, a lot of the discussions around fire and forest in the U.S. focus on the Western U.S., but they're asking about research being done on fire in Eastern hardwood forests. Anything you'd like to share on that front?
Well, these are great questions, and each one is actually like a really, really big question, an important question that we could spend a lot of time on. Let me try to say this really, really succinctly, because I know we're kind of running low on time here. But Fire is natural in the eastern forest generally. It's natural in the western forest, but it doesn't mean that fire regimes are the same. They're generally not. There are certain forest types in the eastern forest where fire is a little bit more similar to what it is in some of the western conifer forests, mixed intensity fire, and with some, maybe even similar fire frequencies. And other forest types, fire, probably was much less frequent, but still natural. But you'd have these longer cycles where you might get these really big, severe drought periods that wouldn't happen very often, would happen actually very rarely, but you might get, larger landscape level fires that would happen from that. But what we have right now is, I think, a situation where the U.S. Forest Service is misrepresenting the scientific data in ways that are they're promoting logging as fuel reduction and slash burning as prescribed burning in eastern forests. And they're also applying prescribed fire in a totally unnatural and destructive way that is applying it at an unnatural hyper frequency that is not helpful to forests. So, it's a big issue, and there's a lot of discussion on this. And I gave a presentation a couple of months ago on this subject, fire in eastern forests, and some of the abuses by the Forest Service. Jen can send around a link to that presentation to folks who are interested.
Yeah, and I'll just add 2 quick points on it, northeast, southeast, in relation to the question. So in the northeast, the forests are miraculously recovering from over a century ago of logging, mostly, if not all, on federal lands, where they're now mature. And so instead of celebrating that and realizing that it's an incomplete recovery because we don't have old growth, the Forest Service is proposing to log the mature, claiming we've got too much of it and not enough early cereal. But they seem to not understand that there's early cereal that's caused by a clear cut, which is vastly depauperate compared to an early cereal that would have been created by fire or insect outbreak or even a hurricane in that region. So they're using that to justify logging mature. And in the southeast, this is not hardwood forest, of course, the longleaf pine wiregrass system, most of the biodiversity is in the understory. And when you have fire suppression, you get saw palmetto, which might be good for a natural remedy to prostate issues, that overtakes the understory, and you lose all the biodiversity because you just have thick mats of saw palmetto. So they're burning on a very frequent basis in that system. Every couple of years, they'll go in and do prescribed burning, and that is maintaining the understory plant composition that's associated with one of the most biodiverse temperate conifer forests in the world, again, in the understory, and tied to its relationship with frequent fire.
Thanks. Another question asks if either of you have any thoughts to share on the implications of the recent Supreme Court Chevron ruling and its implications for legal enforcement related to forest and fire policies.
Yeah, I mean the recent ruling by the Supreme Court overturning the 1984 Chevron decision, which basically eliminated the deference doctrine, at least one type of deference to agencies. In some ways it could cut against the environment in certain contexts. When it comes to forests, there could potentially be some benefits in the sense that over the years under the Chevron doctrine, courts have sort of blindly, in some cases, blindly deferred to the Forest Service's interpretation of the environmental laws that they're supposed to apply and the regulations implementing those environmental laws. And that deference to their judgment and interpretation means the logging projects go forward. And so they get the benefit of the doubt. They're assumed to be right unless they're proven wrong at a very, very high level. And that's very difficult. It's a very difficult hurdle to get over the way it's been applied. And now, so that bar is not up here anymore. It's a little bit more of an even playing field, at least as to their interpretation, the Forest Service interpretation of statutes and regulations implementing statutes. So there could be some benefits, but it's really early days and we'll just have to see how it shakes out.
Do you want to add anything, Dominick?
No, I think Dr. Hanson did a wonderful job of articulating that succinctly.
Great. Then I will ask a next question that I think, Dominick, you'll be excited to answer, which is, what do you propose for building materials other than wood?
Yes, indeed. So when my community burned down in 2020, we were looking at that issue, and I actually started a company at the time, and it went belly up, unfortunately, because the city wouldn't approve what we were trying to do. So there's all kinds of substitutes. We were looking at recycled steel, hempcrete, and other non-wood-based materials to reconstruct the town, but we couldn't get past the building codes, and the whole thing went and collapsed. And it's unfortunate because, you know, we cut down the forest, which is contributing to the problem that I mentioned, and then we put them in the houses, which then are flammable and burn up in these urban catastrophes. And we're really indifferent to, or actually resistant to, using alternative materials, and they're out there. They just, you know, we just need to start using this more often and having some demo projects and getting the damn insurance companies to reward homeowners that use alternative building materials and that use home hardening approaches. But it's a real uphill battle, not only with the building codes, but getting mortgage approved with alternative structures, and also, you know, getting home hardening built into buildings that are burned down. And I think it's going to take more concerted action. And I'll just kind of flip it back to Chad for a bit here too, because, you know, we now have our presidential nominee, Kamala Harris, running. And at one point, if I'm not mistaken, JMP was working with the Harris folks on redirecting funding for some of these issues related to home hardening and dealing with the rebuild cost of that. So I don't know if you want to chime in on that again, Chad.
Yeah, I'll just briefly mention it. Yeah, we John Muir Project and some other organizations worked with then Senator Harris when she was in the Senate before she became Vice President Harris, and on legislation that would really focus on community safety from wildfires, home hardening, defensible space pruning, evacuation assistance. Really take a community-focused, a community-directed approach, and that was called the Wildfire Defense Act. And she introduced that bill, to her great credit. And unfortunately, none of her colleagues in Congress have reintroduced it, which is its own problem. But she had the courage to do that at the time, which we thought was encouraging, and hopefully she will carry forward that vision when she's elected.
Great. Okay, we're getting near the end of the time available, but let me just maybe do one final question, where the person raises the point that so much of the public attention, media attention on fire has focused on forests, when grasslands and shrublands are often the big places where that's occurring, particularly in California. Is there anything either of you would like to say about non-forest lands in relation to fire and climate?
Absolutely. But Dr. DellaSala, if you'd like to go first, I'd be happy to follow. But I certainly have some thoughts on that.
Oh, why don't you take it?
All right. Well, yeah, this is a big issue. You know, we know that community safety from wildfires is not a forest issue, certainly not exclusively. It's really not about the vegetation type. And in fact, fires move much faster toward towns through grasslands or chaparral or oak savannas than they do through, you know, a dense conifer forest. Dense conifer forests, fires move the slowest slower there than they do through any other forest habitat type. When more biomass, slower fire spread. There's nothing faster than a grass fire, and we saw that in Colorado, you know, a couple of years ago, and we've seen it in many other places. The most recent example, and I had an opinion editorial article in The Hill 2 days ago on this about the Park Fire. And there was a lot of misinformation in the early days of the fire with logging industry and its political allies trying to say that the fire got so big so fast because of overgrown federal forests. And that was just an outright misrepresentation. So what I mentioned in my opinion editorial article is that about 3/4 of the fire was in grassland and oaks, a very, very open, low density oak savanna. And the remaining 1/4 that was in conifer forest, most of that conifer forest was private industrial timberlands that had been heavily, heavily logged for many years, even decades, and much of that thinning, by the way, also clear cutting. And so the idea, this notion that it's because of overgrown federal forests is just ridiculous. And in fact, in the intact unlogged federal forests that the fire burned through, that were dense, which is a tiny percentage of the fire, the fire burned through at relatively slow rates. So none of this stood up to scientific scrutiny, and it's just an example of all the fallacies being used to promote sham logging bills like the Fix Our Forests Act or the Save Our Sequoias Act, and they always have deceptive names like that. These are just logging bills that would just make matters worse across the board. So yeah, this is a community protection issue. It's not a forest issue or forest management issue. And anyone that's promoting that notion is really putting communities at greater risk. But by the way, before we sign up, I just want to say big thanks to my friend and colleague, Dr. Dominick DellaSala, for your presentation and including overcoming some technical difficulties. Thank Doug Bevington for moderating, and big thanks to Jen Mamola for troubleshooting all the technical difficulties, and for all the links to these key sources that she's put in the chat. Much appreciated. And big thanks to everyone who showed up to participate and listen to this discussion and ask all these great questions.
Yes, thank you all. And repeating what Chad said there in terms of the thanks, much appreciated. And I wanted to remind everyone who joined us that the next webinar in this series is going to be Wednesday, August 28th, again at noon Pacific time. And that one the theme is going to be rethinking fire management beyond backcountry logging. And that's going to be with Dominick again, and also Luke from Klamath Forest Alliance. So I hope you can join us for that. This webinar has been recorded, so I believe that'll be available. Jen will have that information. And again, encourage you all to get the Nature's Phoenix second edition book. We have in the Q&A section how you can get it through Elsevier, and someone pointed out that I think currently the best price on it is available through Barnes and Noble. And there'll be other resources on this front as we go into the next webinars. So again, thanks to our speakers, thanks to Jen for all she did to organize this, and thank you to everyone who attended, and thanks for your great questions. I'm sorry we weren't able to get to them all, but I thought they were very helpful, productive questions. I hope you found the answers useful too. So, everyone take care.
Thanks, everyone.